Yeah, hi. I'm Yannic. I'm the second co-founder of tipi.build, and tonight I'm going to talk to you about a weird thing that we've been doing this year. A bit of the backstory of why we came to do this. Anyone here familiar with wine? Okay, that's good, folks. Anyone using MSVC from time to time? The same. Awesome. We kind of had that business requirement of a customer that did want to do something with distributed builds, and MSVC and the partner platform that we were using or are using didn't actually support build distribution on Windows, so we had to figure something out. And we had that, hey, we could, because like a compiler doesn't do like crazy stuff. There's not much graphics going on. It's basically file access and I/O. And we thought like this should be something that Wine should be capable of. Let's give it a try. Let's time box it for a day. And so I hacked away a day. At the end of the day, I was ever slightly smarter than at the start of the day, and came to the conclusion that yes, we should be able to do this. Let's expand the time box for a week. And this story kept on repeating. In the end, it took us the better part of about 3 months to get this thing running. Yeah, why would you do that to yourself? So we had that real business requirement, that build distribution, targeting Windows builds. We only had Linux as a runtime, but we needed MSVC because requirement. So we had a couple of good reasons. The requirements, we knew launching processes under Linux is way faster, and compiling is launching a lot of processes. And file I/O is typically better. It's better out of the box for the most part because there's no antivirus. File systems are a bit faster than good old NTFS too. And so there's another slew of reasons not to do this because, like, if it was easy, someone else would have done it before. And we found a couple of people that wrote about having done it and how to do it. And everything looked like a horrendous mess. So, well, we did it again. The first real challenge was actually getting a working installation of MSVC on a Linux box. And whereas I can now confidently say that running the compiler itself on Wine is quite easy once you figured out how to align the universe, the installer is a completely different story. So Microsoft has this wonderfully complicated online installer, and the error messages and debug traces I got out of Wine crashing on me when trying to run this were things I looked at for about 30 minutes and abandoned because this was beyond what I was willing to go through. But I figured out that a 1.5 megabyte installer couldn't be doing like super complicated things. And I looked into how they actually built it. Turns out they have a huge JSON file somewhere on some CDN. And so this is about 80%, the last column didn't fit on the screenshot, of the Python script that is replicating the behavior of the Microsoft Visual Studio installer. So this thing grabs that JSON file, downloads about 14 gigabytes of wild mix of EXE files, zip files, Visual Studio extensions, etc., and knows how to unpack everything to the right spot in the system to create a functioning Visual Studio installation from scratch. And there's a lot of super interesting details here. For example, what happens when you have Windows, which is typically, it's not ignoring casing in file path, but it is semi-agnostic to it in terms of you can have a folder or a file which has upper and lower case mix, but you cannot have another casing of the same letters residing next to it. And it turns out that Microsoft ships zip files and installers that have actually slight variations of casing in the path they do extract. So this portion of the code here is actually doing a file tree traversal and unifying subtrees that have only casing differences in the path. So this was really good fun. It took me about 4 weeks to figure every nitty-bitty detail out. And the inconsistencies, for example, for these files go down to the casing of includes in headers. So one small detail, which is, I think, here somewhere, for example, creates symlinks for all lowercase and all uppercase variants of some headers so that the includes work out in the end. And then I thought I can launch CLXA and just build a main. I'm so close to it. And I was just like 4.5 weeks into the story. I was convinced I'm so close ahead to cracking that nut. Turns out there's an evil thing there. Who knows VC vars all here? Okay, so basically when you run Visual Studio or on the command line, you use the developer console. And this is just basically a command with a lot of settings in the environment. And this VC vars all knows all the details about what is required to make MSVC happy on your installation. And Wine has a CMD interpreter, so I shall be good to go. Well, it turns out that besides more tricky things like PowerShell not being present in a Wine installation and really hard to get to run, and a couple of missing system tools, Wine was failing on interpreting expressions like this, which are everywhere in VC vars all and the linked scripts. And after a lot of guesswork to actually figuring out that the command line interpreter wasn't doing what it was supposed to, and thus creating like silent entries in the wrong code paths, because it was not failing. It wasn't stopping there. It's just choosing the wrong path every time. So, well, it went the way of the dodo, because in the installer I actually knew everything I needed to know because I was deciding on every path. So, welcome. Wine MSVC host, x86, x64, ARM64, target, blah, which is 7 copies of this beauty, which is 27 environment variables set for MSVC to be happy. And there's very little documentation about what is actually required. So then I was ready. I was typing, and MSVC was happy. I was able to compile slightly more complicated things using stuff out of the Windows SDK. It's like, okay, let's put it together. Let's have TP, which is, among other things, generating CMake build scripts and running CMake, call into this beautiful things that I just created. So the thing is, TP and CMake run in our system here, don't run in Wine, because there were other, like CMake running in Wine didn't really go so well. And so we run everything on the Linux host and execute in the emulation. And it turns out that CMake is quite aware that something is going on. So it knows that it's actually dealing with MSVC, in spite running on a Linux host. And it generates all the right switches. It can do compiler detection. It's quite magic to see. Like the first time I saw the log output and saw CMake running Gmake, executing CLexe in Wine, I was just like, this is wrong, but it's awesome at the same time. It's just that CMake doesn't really have the code path, or was never thought to be to do this. And so there's a funny mix of things going on. And as you see, CMake is actually generating Windows-style command line arguments here with forward slashes for the flags. It turns out that is a very bad idea when you mix this with Unix-style paths, which start with a forward slash. So MSVC got really confused there, especially when, as we do, you mirror source code into /user something, and there's command line switches which start with /u. So we build intercalaire. So I'm half French, so I'm entitled to choose French names here. Intercalaire is basically the French word for something, a sheet of paper you insert between other stuff. And it's a shimming application that knows how to rewrite the command line in order to do impedance matching between these two words. And it's an application that CMake is calling to call CLexe, and that runs on Linux, and it knows everything about all the tools in the MSVC compiler collection, and it knows about, I think, most, if not all, command line arguments. There's a couple of them. So this is just the listing. So this is C++, it's 4 C++ arrays or vectors of all the arguments of just CLexe, and there's like 14 other programs we have this detailed listing for in order to be able to compute like substitutions and when to start a Windows-style path after a flag and funny things like this. And it does like a couple of more things for response files and details. Basically, CMake calls this, so it says we replaced the compiler launch command with intercalaire, and then we start CL, and we give it a couple of parameters. It does its magic, and you get Windows-style paths. And so the Z drive here is a special thing in Wine, which basically maps to the root of the host file system under Linux. And it turns out that MSVC is very, very happy with this happening. And everything else was really smooth sailing thereafter. Now, you might ask, was it worth it? Hell yes. We have cheaper and way faster compute in the cloud when we use Linux-based machines. We actually can measure 10 to 20% increase in build speed just because of the process model. And I have some benchmarks and I can show you a bit of stuff afterwards. We can do cross compiling, which I find awesome. And again, we tested this with the binaries perfectly running natively on a Windows 11 running on a Parallels VM on a Mac, I think, Mac M2. That machine back there. We can now distribute the builds. So we can actually run MSVC builds on 10,000 cores. And it's wonderfully weird, and just for that reason, it's fully in right to exist. And so this is what happens if I'm using this on my laptop. So just compiling everything of Boost, using the native MSVC 22 on the machine and giving it all the best chances. So I disabled file access time on tracking on NTFS. I disable my antivirus scanner. I'm getting about 12 minutes build time for the whole of Boost. And then I go into VSL, which is a virtual machine running on my computer. I can just shave like 4 minutes off the thing, 3 minutes, 3 minutes off the thing. And if I'm going to some machine which is not thermally limited as this small laptop, I'm actually, it's still about 18% difference, but this is like, it's a clean build of Boost, and it's just like nearly there. There's no caching, no nothing in this example. You guys can try it. Go sign up to the website. If you activate the trial, you get the cloud resources. There's examples online. You can just try it. And now let's have a bit of, where's the screen? Yep. So Beauty is a web framework based on Boost, ASIO, and Beast. And then this is on top. It's basically super useful. Where's my mouse? So, wrong screen again. So, because we were discussing CMake stuff and CPM before, this is how you declare the inclusion of Boost in tipi. You basically say, I want Boost.org.boost, which is omitting the github.com part in front. And you say, I want 180. I want to use Boost file system and system here. That's basically it. There's a bit of configuration required for both environments. So the Visual Studio 219 and the Linux Wine MSVC, which need some compiler flags and some definition that which Windows version we target. And other than this, it's basically out of the box project that you can find on GitHub. And so let's just make sure that we erase everything on both systems that could. So we have an empty source mirroring and build folder mirroring on the cloud machine that we're talking about. And where's the Explorer? This is how this mess looks like on my work environment. And if we just go by date of modification, okay, for the other example, I can delete that I'm not doing on my computer. Otherwise, we are 10 minutes in. So we don't have Beauty, and we don't have it remotely neither. And now let's just that's unfortunate. That was the wrong side. So that's the local build with this, and this is the remote build with the Linux one. Okay, that was unfortunate. Trying to access the same files at the same time here. Yes. Windows file locking. That's unfortunate. Let's do just the remote thing here. The both example I actually wanted to do on MIPP. Yeah, so we are synchronizing the sources to a remote machine here, and then we will do the whole build. So basically shipping Boost, which you will see it in just a second here. I really hope for the internet connection to be nice with me, because I had a couple of failures this afternoon. So we are fetching Boost from GitHub here, as you can see, and checking out the 181 submodules. I could. Yeah, so if we want to make it fair, I should remove boost from that side. No, there's still something locked. The Git repository stays open. Yes. Yes. There. Just behind your.
Question?
Yeah, maybe it's more like an invitation to the discussion, but from your question at the beginning, why would you do that? I mean,
Yes.
I would be really interested what your customer requirements were there.
So I cannot go into deep detail there, but basically they were using a heavily customized Clang code base or LLVM based code base that they needed to compile for a Windows target. And they had regulatory requirements to be doing this with a official or certified compiler. But they had like a scale issue in terms of it's so slow that we consider spending a lot of money to distribute the build over a massive amount of machines. And so, okay, so we had the internet connection fail on us here. So we lost the output, sadly. I don't know how far we got into the boost thing. I measured this about 20 times today, and this is a slightly bigger machine than the one I was doing my benchmarks and the slides with. So it has 128 cores. So, and it does the build of Boost and the web framework on top with all its samples and examples and tests in about 180 seconds or so. I should have not typed clear. We could have looked at the measurements. And the other project I could show is called MIPP. This is a very cool library done by a couple of Italian guys, which is a nice way of writing SIMD code with a couple of templates, and they have some runtime detection for vectorization differences across systems that have different width SIMD units. So if you have AVX versus SSE2, for example, you can have vectors like 6 times the size or 8 times the size. And it's quite, I like their approach to this. And so the build using, on this computer, using Visual Studio or MSVC 19, basically takes about a minute and a half. So this is about the speed you can expect. There's 80 something files before we get to the examples. Already there. I think it goes to Z. No? And so for such a not huge project when you compare this to for example, Boost. It's actually well worth paying the overhead of network transfer and everything involved to do the remote build, because it's just insanely faster. So basically, the time it takes to synchronize everything is about the time it takes to build, and both together are way shorter than waiting for my puny laptop here to do its best work. And we should be done. Where's... Sorry? So it's on 8-core, 16-thread machines with 32 gigs of RAM. And so we have our web framework being done here. And well, basically, it's about a touch under 3 minutes to get it to work. And so we have a bit more work because we want to use this cool environment for test execution and stuff, because there's still a lot of things that you can do with Wine nowadays. Thanks, among other things, to the work that, for example, what Valve put into making the Proton layer for the gaming stuff. So there's a lot of cool opportunity there, even though we can't really consider it being a one-on-one replacement to a full Windows laptop or something. So again, go try it. It's really cool. There's a lot more in there, so we can do the same for Linux environments. We can do the same for Mac environments. And now it's the end. Questions, and thereafter pizza, I hope. Yes, please. Just one second. I think you will get a mic, so yes, the online part can enjoy.
Thank you. So if you build this thing using Linux, it's faster, but you should get the same executable coming out.
The executable is absolutely identical.
So can you do an MD5 sum on both of them?
So we would have to do a tiny bit of fingerprinting, because most code bases have tiny variances that just result in, and compilers are not 100% reproducible most of the time. So we would have to do some trickery, but in terms of things not related to these differences, the binaries are identical. Taking same compiler, installation, exact version on both ends.
Thank you.
Yeah, so do you build just with MSVC, or do you support full Visual Studio in this environment? So why I'm asking, extensions, cross-compiling, and other bits that are available through VC project?
So it's a really interesting mix. So basically the answer is no. This doesn't touch your IDE. You can integrate it with your local installation of Visual Studio if you want, and have TP run instead of launching MS-Build or something, and have that experience with a remote machine and everything. However, you're basically, we are really just executing the compile. We don't even run MS-Build, for example, on the server side. So if you did some crazy things with that platform, it's not going to be running, because MS-Build is a .NET application which currently requires .NET 4.8 something at least, which doesn't run on Wine. And so we actually run Ninja on the server side to drive CL. Then exactly. Thanks.